Hello, my name is Saida Mussakhojayeva and I am a data scientist at ISSAI in Nur-Sultan City in Kazakhstan. Today I'm going to present our project on KSC2, an industrial-scale open-source Kazakh speech corpus. The outline of my presentation is as follows. First, I'm going to provide an introduction, then give some background information on Kazakh language as well as what has been done before. Then, I'm going to describe the procedures and provide details on the dataset construction, followed by the description of the initial speech recognition experiments and the results obtained. Finally, I'm going to conclude the presentation and provide some directions for future work. Automatic speech recognition technologies have surged as there is an increased demand for speech-enabled applications such as voice search, virtual assistants, and various applications in healthcare. However, data requirements met by industry in building deep learning models are not often available to academia. To tackle this issue, we present KSC2, a large-scale Kazakh speech corpus that enables to bridge the gap between industry and academia. KSC2 subsumes two previously presented corpora, KSC and Kazakh TTS. In total, KSC2 presents 1,128 hours of spontaneous and read-style recordings. The data was collected from TV news, programs, parliament speeches, and podcasts. KSC2 also extends KSC with additional 238 hours and Kazakh TTS with additional 48 hours of data. Finally, the value of KSC2 comes from the fact that it contains Russian-Kazakh code switching data. To give some information on Kazakh language is the official language of Kazakhstan spoken by over 16 million people worldwide, mainly in Russia, China, Mongolia, and others. It is an agglutinative language with vowel harmony belonging to the family of Turkic languages. There are some previous Kazakh speech corpuses collected. First, Yerbolat, whose work introduced 78-hour corpus recorded with the help of 96 students. However, the dataset contains reading-style recordings only, and it is not representative of the general public, as only students were involved in data collection and recording. Next, we have a corpus of 123 hours developed by Makhambetov, but it's not publicly available and therefore cannot be examined. IRPub Babel project also released Kazakh language pack, which contains 50 hours of conversational and 14 hours of telephone speech. The most related datasets are Kazakh TTS and KSC. Kazakh TTS has 271 hours of high-quality recorded speech from 5 speakers. However, it lacks a wide range of speakers to build a robust ASR system. KSC consists of 332 hours of transcribed data crowdsourced over 1,000 volunteers. It is collected over the internet by asking volunteers to read sentences displayed in a web browser. KSC contains only read speech recordings, with no spontaneous data and code switching data. Now I'm going to provide specifications on how KSC2 was collected. As I previously stated, KSC2 extends the previous datasets. In KSC2, there is an additional 238 hours of crowdsourced data. All recordings were rechecked by ASR system and human transcribers. KSC2 extends Kazakh TTS with 48 hours of data. Data sources include books and various news articles. Moreover, our corpus introduces new sources of data. We have 104 hours of television news, and the recordings were obtained from Habar Agency, one of the largest broadcasting companies. Television news contains read speech and interviews. We also have TV programs, 6 hours. It follows a single talk show format with spontaneous speech. TV program has code switching data and overlap speech. Next, we have radio programs in the amount of 48 hours. It contains news, music, interviews, discussions, and call-ins. Code switching and speech overlap are also present. Next, we have 23 hours of parliament speeches. It is a 20 talk sessions given by deputies from official parliament YouTube channel. Speeches are delivered either in Kazakh or Russian. Finally, we also introduce 56 hours of podcasts. It is conversations contain both scripted and improvised speeches. The code switching data is also present. When it comes to data segmentation and processing, 5 native Kazakh transcribers were assigned to do this job. The segmentation and aligning is done using the Prat toolkit, and all the texts were represented using a Cyrillic script consisting of 42 letters and 5 symbols. Finally, all recordings were moderated and rechecked using existing ASR solutions. Now I'm going to explain how we set up the experiments. To validate the reliability of KSC2, we conducted speech recognition experiments using transformer-based ASR with ASP.NET TTS toolkit. During decoding, a character-level language model was utilized. The corpus, training recipes, and pre-trained models are provided in the GitHub repository. The performance on KSC2 is evaluated using character error rate and word error rate metrics. In addition, we perform data efficiency experiments. In this table, we can see CER and VER results per each source. This table shows that the quality of dataset is indeed high, as the CER and VER results are valid. Next, we also perform data efficiency experiments on validation and test sets. This table shows that adding the data from various sources reduced the overall CER and VER metrics. And the VER improvements mostly come from the evaluation sets of reading style sources. To conclude, we present KSC2 dataset with a total of 1,127 hours of data. KSC2 contains both scripted and spontaneous speech, as well as code switching data. The dataset is freely available for both academic and industry practitioners at our GitHub repository. The quality of KSC2 was demonstrated by performing preliminary experiments and achieving competitive evaluation metric scores. For future work, we plan to collect additional spontaneous and Kazakh-Russian code switching data. This concludes my presentation. Thank you all for your attention.